Uh, Good evening. So we'll start a derivation on effective EMF in parallel. Okay. Now you can see here two cells are connected. Its individual EMFs are E1 and E2, and its individual internal resistance are R1 and R2. Okay, and they are connected in parallel. And current is flowing from this cell, and the amount of current is denoted with letter I1, and the current flowing from this is I2, and these two currents meet at this point, and the effective value of this is called as I. Okay, and let me mark this as point A and it is point B. Okay, the effective of these two can be redrawn here, and that value is given by EP, and this point is A and this point is B, and internal resistance is what? RP. Okay, so let's derive an expression for EMF in parallel. Okay, right. So to do this, we will use a formula, that is I is equal to E minus V divided by small r. This expression we had derived it earlier, that is I is equal to E minus V divided by R. Okay, first let me write the expression for current I1 here from that equation. So I1 we can write it as I1 is equal to E minus V by R. What is E? E is what? E1 minus V. What is V here? V from A to B, that is VAB divided by small r. What is small r here? Small r we have to take it as R1. Okay, and similarly now I2 expression from that. Okay, what is I2 is equal to? I2 is equal to E minus V by R. What is E here? E2 minus V. What is V? VAB divided by R. What is R? R is R2. Okay, right. Now these two current meet here, and the effective value becomes equal to I. That is from the Kirchhoff current law. What is that? I is equal to? I is equal to I1 from I1 plus I2. Okay, what is I1? I1 is equal to this much, and what is I2? I2 is equal to this much. Let me write this equation now. Okay, what is I is equal to I1? I1 is what? E1 minus VAB divided by R1 plus what is I2? I2 is equal to E2 minus VAB divided by R2. Divided by R2. Okay, right. Now let me write the expression for I using this expression. What is I is equal to E minus V by R. What is E here now? E is EP. Okay, so E is EP minus what is V? V is VAB. VAB divided by R. What is R here? R effective, that is RP, is equal to E1 minus VAB divided by R1 plus E2 minus VAB divided by R2. Okay, right. This is the equation. Now let us take the LCM of this. Okay, so let me erase this part. Okay, I think you take the screenshot of it. All right. Okay, so let me write this solution. I will rub this diagram. Okay, so my EP minus VAB divided by RP expression turns out to be like this. Now R1 R2 is the LCM. Okay, then E1 into, I will multiply this with R2 and this with R1. Okay, so E1 into R2 minus VAB into R2 plus E2 into R1 minus VAB into R1 VAB into R1. Okay, right, divided by R1 into R2. Okay, that's is equal to, now so E1 into R2 minus, sorry, that write this plus E2 into R1, then minus what is common here now? VAB common. I will take it VAB in a bracket. What is the remaining term? That is R1 plus R2, and whole divided by is what? Whole divided by is R1 into R2, which is equal to what? EP minus VAB divided by RP. Okay, right? So then so EP by RP minus VAB by RP. Let me write this equation like this, and is equal to E1 into R2 plus E2 into R1 divided by R1 into R2 minus VAB into R1 plus R2 divided by R1 into R2. Okay? Right. Now if you compare this equation now, EP by RP minus VAB by RP is equal to, now EP by RP means this term is equivalent to EP by RP, and this term, remaining term, is like VAB by RP. This VAB and this entire remaining term, this VAB by RP, this term is 1 by RP, is equal to what? 1 by RP. That means we can write 1 by RP to be equal to, 1 by RP to be equal to what? R1 plus R2 divided by R1 into R2. Okay, that is for two cells. 1 by RP is equal to R1 plus R2 divided by R1 into R2. So now what is the expression for RP? RP is equal to what? RP is equal to, if you take the transpose of this equation, R1 into R2 divided by what? R1 plus R2. So RP is equal to R1 into R2 divided by R1 plus R2. So let us keep this equation aside. Okay. Now that means EP by RP expression is equal to what? This much. That is what? E1 into R2 plus E2 into R1 divided by R1 into R2. Now what we want? We want EP now. That is nothing but your effective EMF in parallel. Okay. Now EP by RP is equal to this much. Means now if you want only EP, means what we should do? We should multiply EP by RP with RP. If multiply EP by RP with RP, we get what? EP. Okay. So let's do this here now. Okay, let's compare this term to this one. Okay, right? So EP by RP. Now if you multiply EP by RP with RP, what we get? We get EP, right? Yes or no? Okay. Now let me write this equation now. What is that? E1 into R2 plus E2 into R1 divided by R1 into R2. For this number, if you multiply by RP, this is what this RP, right? That is that R1 into R2 divided by R1 plus R2. What we get? We get R1 R2 gone, R1 R2 gone. What we get? E1 into R2 plus E2 into R1 divided by what? R1 plus R2. So this is what your EP value. So EP is equal to how much? EP is equal to E1 into R2 plus E2 into R1 divided by R1 plus R2. So this is the expression for what? Effective EMF in parallel of two cells.